Okay, so now let's continue with the example 2. Again, we are given a strong form. So it is the second derivative of u with respect to x is equal to 0. And the domain is between 1 and 3. Now, at x equal to 1, the derivative of u is prescribed. So du dx is equal to 2. And at the x is equal to 3, the displacement, or u, the dependent variable, is defined, and it has to be equal to 1. Now, first, we multiply this differential equation with the weight function, and then we apply integration by parts. So we arrive at this equation. So it is w du square dx square is equal to then w du dx at x is equal to 3 minus w du dx at x is equal to 1 minus from 1 to 3 dw dx du dx dx, as you see. So it is once more again w d square du dx square, integration of this expression, is equal to w du dx at x is equal to 3 minus w du dx at x is equal to 1 minus from 1 to 3 dw dx du dx dx. Now here the point comes. Remember that at the essential boundary, so where x is equal to 3, the weight is equal to 0. Therefore, this term vanishes because it is 0. Now we are left with this expression, and this is equal to 0, as you see here. So again, it is minus from 1 to 3 dw dx du dx dx minus w du dx at x is equal to 1 has to be equal to 0. Indeed, this is not a bad approximation. If nothing will change if I multiply this expression with minus 1. And then I substitute the value for du dx. So remember that at x is equal to 1, du dx is equal to 2. And as a result, I'm left with this expression. And this is the weak form for my problem. Okay, so this is how we arrive at the weak form. Now, let us show that this weak form is equivalent to the strong form. For this purpose, we will just take this expression and then apply integration by parts to this expression again. Now, this gives us this final expression. Let's take a look at it. It is dw dx du dx. Certainly, if we apply integration by parts and saying that this is u, this is v, this is w du dx from 1 to 3 minus 1 to 3 w du d square u dx square. Okay, now I can write the boundary terms separately. As a result, I'm left with w du dx at x is equal to 3 minus w du dx at x is equal to 1. Now, this is my boundary term. Then I substitute this expression. It is from 1 to 3 w d square dx square dx, and from here I have the term which comes again from the boundary. So basically I substitute this term into this equation, and it gives me the final expression of this whole expression. So this is what I get. Now remember that w at x is equal to 3 is 0 by definition. So again, this term will vanish because of the weight function, definition of the weight function, because the weight function is 0 at the Dirichlet boundary condition or essential boundaries, on the essential boundaries. And then if we simplify this expression and multiply the whole expression with the -1 again, in order to avoid the sign confusion, we arrive this final equation. Here 1 to 3 again, we have an integral from 1 to 3 w d square u dx square dx plus w multiplied by du dx minus 2 at x is equal to 1. And this expression has to be equal to 0. Now the point is this: since w is arbitrary, so the weight function is arbitrary, I can choose any function for w. Now I made a choice. I choose such a function so w is equal to some function phi x d square u dx dx square and I can choose this function in a way that it is 0 at the boundaries, so at x is equal to 1 and at x is equal to 0, so it is 0 on the boundaries, and it is non-zero within the domain. I can choose, since w is arbitrary, I can choose such a function as soon as the function itself, as soon as this function is positive. And then I substitute this expression into this equation here. And here. So I can do that. Okay, now this basically means that, so in order this expression to be 0, certainly this integral has to be 0 and this integral has to be 0 independently, or this term has to be 0. Let me show it in a different way. So this basically means that this term has to be 0 and this term has to be 0 independently because of the choice. This is the only way that this expression is satisfied. Okay. So basically, again, I will repeat, this expression has to be 0. Now, since this function is positive, we choose it so. The only way that this expression is satisfied is that this term is 0. This is the only way. If this is 0, because it is the square of d square u dx square, this term is always positive. And remember that we choose this term as positive too. And multiplication of these two terms is positive. But we know that this integral has to be 0. And the only way that this integral is to be 0 is this term. So d square u dx square is 0. This is the only way. Now, second of all, we look at the second term. So remember that w is arbitrary. Since w is arbitrary, we can choose any function. And the only way that this term is 0 is the expression inside the brackets is 0. This basically means that du dx minus 2 at x is equal to 1 is 0. This validates that weak form. So the weak form, this one. This weak form is equal to or equivalent to the strong form given in the problem. So this is the weak form, and this is my strong form, and these two are equivalent.